Hello everyone, I'm a 4.0 pre-med and today I wanted to go over halogenation with all of you guys. I know that it's a very weird mechanism and some students were asking me to please make a video on it, and so here it is. So as the name implies, halogenation is going to be dealing with a halogen, and if you go to your periodic table you'll see a group of halogens like bromine and chlorine, and that's what I'm going to go over today because that's what you see the most in OChem 1. So before I get into the actual mechanism, I just wanted to say to please follow, because I made an A in OChem 1 and OChem 2, and I know OChem is a very hard subject for a lot of students, and I want to help as many students as possible, and that's my goal, and that's why I made this channel, to help all of you guys. So please like, follow, share, and send to other students. Okay, let's get into the actual mechanism. So I drew regular alkenes, okay? The double bond is a pair of electrons, and that's going to go and attack the bromine. But the way I like to think about it is that bromine, remember, bromine is more electronegative. Fluorine is the most electronegative element on the periodic table. And so bromine is close. And so if you think about it, bromine is very electronegative. And so it's more electronegative than carbon. And so it's also going to be attracted to that carbon because carbon is more electropositive. And then the pair of electrons between the two bromines are going to go to the other bromine. And then what you're going to form is bromonium. But notice that it's positive. And students are like, wait, why is this positive? You just told me that it's electronegative. Well, notice and calculate the formal charge. Again, if you don't know how to calculate formal charges, I have a video on that, so you can go check that out. But the formal charge ends up being +1. And that's why you have that positive charge. Likewise, the bromine that gained those electrons from the first that we saw has a negative charge. And again, that's because of the formal charge. Anyways, bromine with the negative charge is going to go and attack that carbon. And then those electrons are going to go to the bromine. Okay, I gave you a sneak peek for the chlorine. Well, after that happens, what you're going to have is the bromines are going to be an antiperiplanar. And I'll explain that in a second. Now let's go to the chlorines. Well, again, the double bond is going to attack chlorine. Chlorine is also going to be attracted to the carbon. The other electrons are going to go to the other chlorine. Chloronium ion is going to be formed. The negative chlorine, the chlorine with the negative formal charge is going to attack the carbon. Then those electrons are going to go to the chlorine. And then again, the chlorines are going to be an antiperiplanar. Antiperiplanar, the way that I like to think about it is that if you look, they are 180 degrees apart from each other. Without trying to ruin my drawing, imagine you have a straight line, and then here you have the one bromine, right? And here you have your other bromine. So if you do that, that's 180 degrees of the circle. So that's why I'm saying it's kind of like a 180. Okay, I hope that made sense to you. Well, that's the way that I like to think of it, and that's how I would describe antiperiplanar, that they're like 180 from each other. Okay, so I know I showed you the mechanism, but I want to show you an example of a mechanism where you have a more substituted carbon, because notice here they were the same, like alkene. So here you're gonna ask, wait, what would I do? And I already gave you the answer. I'm letting you cheat. So halogenation is anti-Markovnikov. If you don't know what Markovnikov is, go check out my video. And if you don't know what anti-addition is, I guess in a way I'm going to explain it in this video, but I should have a video on that as well. Okay, so let's go to the nitty-gritty. The electrons are going to attack the bromine. Bromine attacks the carbon. Other electrons go to the bromine. Same exact thing. And you form your bromonium. But what happens that's different? The bromine is going to attack the more substituted carbon. And then the electrons are going to go up to the other bromine, as we saw up here, right? But notice it's attacking the more substituted carbon. Okay? And then Also notice that you're forming enantiomers. Here, I didn't form enantiomers. I just showed you the antiperiplanar position. And if you notice, you have enantiomers here because you have chirality. And that's why you have chiral centers. So, one more thing to notice. This bromine that I have very highlighted now that you barely see the electrons, so I'm going to take off that. Oops. I'm trying to delete without deleting the R. This bromine that's in blue, it can attack from the front or it can attack from the back. If it attacks from the front, this bromine is going to be in bold. But it's anti-addition, so the other bromine is going to be in dash. If it attacks from the back, again, this bromine, then it can be in the back, and the other one is going to be in the front. So notice that. Again, if you like this video, please follow. I want to reach as many students as possible. I want to help as many students as possible. I made an A in OChem 1 and 2. And for me, it was really easy, but I know a lot of students suffer in the class, which is why I made this channel, which is why I make these videos, because I want to help you guys and I want you to succeed. And so please share with as many students as possible. Please like and comment and let me know if there are other questions that you guys have or mechanisms you want me to go over or whatever in organic chemistry. And happy studying.